Good day, my unique viewers. You are welcome to Understanding Chemistry by Nkechi. Today's lesson breaking at Faraday's law of electrolysis. So the first and second law of electrolysis as proposed by Faraday in 1833. So the first law of Faraday states that the mass of element discharged during electrolysis is directly proportional to the quantity of electricity passing through it. So from the definition, mass varies directly proportional to quantity of electricity passing through it. So it means that the quantity of electricity increases, the mass of element deposited will also do what? Increase. So M is mass in grams, quantity of electricity is the unit is in coulombs. So if I remove Q, it's also what? Q is equals to current times time. Current times time is the quantity of electricity. So where current, I is current, the unit is what? Is ampere. Time, the unit of time is seconds. So we are given time in hour or minute. Convert it to what? You must convert it to seconds. So which means mass is also directly proportional to what? Since Q is equals to IT, very directly proportional to IT. If I remove this variation sign, I will introduce a constant, and that's what we call electrochemical equivalence. So this Z is electrochemical equivalence. So Z is electrochemical equivalence, and the unit is gram per coulomb. So Z is relative atomic mass of that element divided by the number of Faraday. So 1 Faraday is equals to 96500 coulomb. 1 Faraday is equivalent to 1 Faraday is equivalent to 1 mole. 1 mole of electron is equals to relative atomic mass. Relative atomic mass of the element. Okay, so we can also establish a formula for this. This is my M. The Z of writing this Z, electrochemical equivalence, is now relative atomic mass, capital M. So your IT, that's the quantity, it could be Q, quantity of electricity. So divided by the number of Faraday. So that number of Faraday, 2 Faraday is equivalent to 2 moles of electrons, equivalent to the relative atomic mass of the element. So I'll use N to designate it. Some textbooks they use small letter C. You see the same thing. So this N is number of if it's a trivalent element will discharge 3 moles of electron. Okay, so look at this. This is a divalent element. So the number of moles of electron here is 2. If I'm doing calculation using this formula method, I'll put instead of this, I'll put 2 here. If it's one of the univalent element, this is one more electron I have here. So here is 1. Let's look at the verification of Faraday's first law of electrolysis. So this is a setup for the verification of Faraday's first law of electrolysis. You can see our electrolyte is silver 2035 solution. Here you have silver cathode and silver anode. Okay. So when electric current passes through this electrolyte, silver is what deposited. So at the beginning of the experiment, you weigh the mass of the cathode, because what happens is at the end of the experiment that there must be again a mass of the cathode, because as the silver ion accepts electron from the cathode, it's going to be deposited here. So there must be again a mass of the cathode. The mass at the beginning of the experiment at time 0 is M1. So when you pass a steady current of 1 ampere for 10 minutes. Once the 10 minutes elapses, what do? You switch off the current supply. You switch it off. So that at that 10 minutes, what do? You weigh the mass. So let it assume the mass is M2. So I want to repeat this experiment, but you change the time, different time interval. At 20 minutes, you stop. You also weigh the mass of the cathode. You can do it up to 40 minutes. So you can see that must be increase in mass as the time is increasing. What happens to the mass? The mass of the silver deposited will also increase. So you can see that Faraday's first said that the mass of the substance deposited during electrolysis is directly proportional to the quantity of electricity passing through it. If the mass of an element discharged during electrolysis is directly proportional to the magnitude of the current and the time of flow of the current. So to plot a graph of gain in mass versus time, duration of time. So you can see you have what? A straight line passing through the origin. So here is gain in mass. You can call this one M1, M2, M3, M4. So this is mass, gain in mass versus time. So here is T1, T2, T3, you have your T4. So obtain a straight line passing through the origin. So let's look at Faraday's second law of electrolysis. The same quantity of electricity is passed through different electrolytes. The relative number of moles of the element discharged are inversely proportional to the charges on the element. The quantity of electricity involved when 1 mole of an element, the quantity of electricity involved when 1 mole of electron transferred is known as Faraday. So use capital F to designate it. 1 Faraday is equivalent to, it's about approximately 9600 coulomb. So by mole concept, 1 mole of univalent element. So which univalent element can one do you know? Sodium ion is univalent, silver ion, potassium ion. So look at this. So this is univalent element, sodium ion, accepted 1 electron to give metallic sodium. So 1 mole of univalent element is equivalent to how many moles of electron? I have 1 mole of electron. So 1 mole of electron is equivalent to 1 Faraday. It's equivalent to 1 Faraday, which is equivalent to what? The relative molecular mass of the element. So what's the relative molecular mass of sodium? That's 23. Then for a univalent, so remember 1 Faraday is equal, so this 96500 coulomb. For 1 mole of a divalent, 1 mole of a divalent element. So example of 1 divalent element include calcium ion, copper, 2 ion, etc. So for 1 mole of a divalent element, it's equivalent to, this 2 moles of electron, and this 2 moles of electron is equal to 2 Faraday. What's the molar mass of calcium? Is 40. So 2 Faraday is 2 times 96500. So for a trivalent element, presents 1 mole of 1 mole of aluminium ion is equivalent to 3 moles of electron, which will give as 3 moles of electron is equivalent to 3 Faraday, is equivalent to 1 relative molecular mass of aluminium. So 3 moles of electron equivalent to what's the relative molecular mass of aluminium? 7. Those are equivalent to 3 Faraday. 3 Faraday is 3 times 96500 coulomb. So we're going to look at verification of Faraday's second law of electrolysis. You can see 2 electric cells connected in series. One compartment contains a copper electrode deep in copper 2 tetraoxide solution. So you can see this the other compartment here have a silver electrode dipped in silver tetraoxide 5 solution. So when you pass the same quantity of electricity into this, what happens is that copper will be deposited at the cathode and silver will be deposited at the anode. Before we start this experiment, what we do in the first verification of the first law, they're going to weigh the cathodes, copper cathodes and the silver cathodes separately, weigh it and note the mass. When we pass a steady current of 1 ampere for 20 minutes, we'll now switch off the current, switch it off the current. So what happens is that we want to check the mass. We're going to weigh, because at the end of that 20 minutes, it means that copper is deposited at the cathode and silver deposited at the anode. So what we're going to do is we check the gain in mass. We weigh it. We weigh this one. So the mass that we have there, let's assume for the copper. So the mass of copper deposited. How do you find the mass of copper deposited? The mass of copper, when you weigh the mass of copper at the beginning of that experiment, then after the experiment, the mass after the experiment minus the mass at the beginning of the experiment will give you the mass of copper deposited. So if the mass of copper deposited is X, the mass of silver deposited, I call it Y. So how do I get moles? Remember, moles is number of moles equals to mass divided by molar mass. So let's look at the moles of copper. Moles of copper. That's X equals to X divided by the relative molar mass of copper is 64. So what I call X mole, I call it S1 mole. Moles of silver. Silver is the mass of silver is 1 divided by the molar mass of silver is 108. So I'll call it. So most of Faraday's the second law. This copper that is the charge is 2 plus. If the mole is S mole, the moles of silver that the charge is plus 1 will be 2 times the number of moles of copper, or one with 2 plus. So here we go, it's will be 2x 1 mole. So remember the law says the number of moles of the element discharged are inversely proportional to the charges on the ion. So if copper is 2 plus and the mole is S mole, the number of moles of silver with charge plus 1 will be 2 times the moles of copper. Okay, thank you viewers. I've come to the end of this video. So next video I'll be uploading will be on calculations involving electrolysis. Thanks for watching. Have a great day. Bye.